In this video, we're going to review vectors and polar graphing. Our first question here asks us to add together two vectors. We have vector u, whose component form is 2, -3. Vector v has a component form of -6, -4. And we're asked to find the component form of the resultant vector when we add vector u and vector v together. So I'm going to start out with component form of vector u, which is 2, -3. Plus vector v, -6, -4. And to find the resultant vector, we're going to add together the horizontal components. 2 plus -6 gives me a horizontal component of -4. And we're going to add the vertical components. -3 plus -4 gives me a vertical component of -7. And so that gives me the component form of the sum of these two vectors. Now the next question asks us to sketch the head to tail model and show the resultant vector. And so I'm going to start with vector u, and we don't have graph paper here, so we're just going to do a sketch. I'm going to start right here. Vector u goes 2 units in the positive direction, 3 units in the negative direction. And so vector u might look something like this. Then I'm going to add to that vector v, -6 units, so 6 units in the negative direction, and then 4 units in the negative vertical direction, and that would be vector v. Now notice I started vector v where vector u ended. So whenever we're adding two vectors, we draw one vector, and then where the first vector ends, that's where the next vector begins. Now the resultant vector is going to begin where our first vector began, and it's going to end where the second vector ended. So that would be our resultant vector r. Next question asks us to find the magnitude and the direction of the resultant vector. We already have the components, -4 and -7. And if I add those to my sketch up here, -4, -7, you can see if you look at the blue there, we've got a right triangle with sides -4 and -7. The magnitude of the vector is going to be the length of the hypotenuse of that right triangle. And so the magnitude of r is equal to the square root of -4 squared plus -7 squared. And this is equal to 8.062. So that gives me the magnitude of the resultant vector. Now to find the direction, we're going to use inverse tangent, because I have a vertical component, I have a horizontal component, which correspond to a y and an x. And so inverse tangent of -7 over -4, and if we put that in our calculator, we get 60.255. Now 60.255, that's a positive angle. That would be an angle that would be in quadrant 1. But notice if you look at our vector, our resultant vector in our drawing above, it's really going into quadrant 3. If I draw a little axis at the starting point there, this is going into quadrant 3. And so I need to figure out my direction. Let me draw another picture here. Here's my resultant vector. The 60 degrees, that's this angle right here. That's the reference angle for the direction of my vector. The angle that I want is this angle. That's theta. And that's going to be equal to 180 plus the 60.255 that we figured out. So the direction of my resultant vector is actually 240.255 degrees. All right, on the next question, this time we have 3 vectors, vector A, vector B, and vector C. We have the component form for each one of those, and it asks us to find the component form of the resultant vector, and then again show a head-to-tail model of the sum. So for the component form, I've got vector A plus vector B plus vector C. Now when we've got three vectors, process is still the same. We're just going to add together all of the horizontal components. And if I add -4 plus 5 plus 6, we end up with 7. And then we're going to add all the vertical components, -3 plus -2 plus 9, and that gives me 4. So the resultant vector has the components 7, 4. And then here on the bottom we need to draw a model of this sum. So I'm going to start with vector A. Let's start right here. Vector A is, both its components are negative. So -4, sorry, let's try that again. -4, -3. So that's vector A. And then, you know what, let me start over again and make that a little bit bigger. Sorry, I was zoomed in so far on my screen, I didn't realize how small that was. Alright, let's try again. Vector A. -4, -3. There's vector A. Alright, vector vector B has the components 5, -2. So I'm going to go, remember that if I'm adding vectors, then the next vector begins where the first vector ended. So from this point here, I'm going to start, and I'm going to go 5 units in the positive direction and 2 units in the negative direction. And so that would be vector B. And then finally vector C. Vector C is going to begin where vector B ends. So this is going to be the beginning point for C. And C goes 6 units in the positive direction and then 9 units in the positive vertical direction. There we go, vector C. So then my resultant vector, remember that the resultant vector is going to begin where your first vector began, and it's going to end where your last vector ended. That would be my resultant vector. And notice the two components that we found, they're both positive, and this is a vector that would have a positive horizontal component and a positive vertical component. All right, let's move on to polar. Here on the polar graphing, it asks us to convert the regular coordinates to polar coordinates and then plot them on the grid. So I've got the coordinates 2 square root of 3 and -2. And I want to change to polar coordinates. And remember, polar coordinates are a radius and an angle. Radius r theta. So in order to find the radius here, so it's kind of like finding the magnitude of a vector. It's the same idea that if I were to plot this point, 2 square root of 3, -2, it's got a x component of 2 square root of 3, a y component of -2. And so to find r, I'm going to use Pythagorean theorem. It's going to be equal to 2 square root of 3 squared plus -2 squared, and that's going to be equal to 16. I'm sorry, this is not what r equals, this is what r squared equals. R squared equals 16. So my radius is going to be 4. And now I need an angle. To find the angle, we're going to use inverse tangent. Of the y coordinate over the x coordinate. And that's going to give us an angle of -30 degrees But since our graph over here is in radians, 30 degrees, that's the same as negative pi over 6 radians. And so now I need to think about, remember that when we do inverse tangent, it's always going to give us an angle in the first or the fourth quadrant, but I need to make sure that that works with my point. If I go back and look at the coordinates of my point, I have a positive x and a negative y, and that means that it is going to be in the fourth quadrant. Negative pi over 6, that is an angle that's in the fourth quadrant, and so that angle works for us. And so my coordinates are going to be 4, negative pi over 6. Or we could also put 4, 11 pi over 6, because that is the fourth quadrant angle that corresponds to the reference angle that we found. And if we were going to graph this, I'm going to go over here to 11 pi over 6, which is the same as negative pi over 6, and count the radius, count the circles, 1, 2, 3, 4. And there's my point for part A. All right, for part B, we're going to do the same thing again. The radius squared is going to be equal to negative 4 squared plus negative 4 squared. R squared equals 32, and R equals 4 square root of 2 if we just simplify, but actually a decimal would probably be better for us for graphing. We get the decimal 5.6. Then I need an angle, so we're going to do inverse tangent of negative 4 over negative 4. And if you put that in your calculator in degree mode, you're going to get 45 degrees, which corresponds to pi over 4 in radians. Now again, we got to think about the quadrant here. If I think about my point, negative 4, that needs to be in quadrant 3. And so this has got to be an angle over here in quadrant 3. And if I go pi over 4 into quadrant 3, that's going to correspond to 5 pi over 4. So my answer here, radius is 5.6, angle is 5 pi over 4. And then if I graph that point, 1, 2, 3, 4, 5, and let's see, let me erase that circle. A little bit halfway, a little bit more than half in between. There's point B. All right, last point here, negative 3, 0. Now on this point, we could go through the same process that I went through on the previous points and find the radius and the angle. However, if you think about negative 3, 0, that's going to be a point graphed over here on the negative x-axis, 3 units out, 1, 2, 3. So it's actually going to be a point right there. And so we could get the coordinates of this point just from looking at the graph. My angle here is pi, and the radius is 3. And so my polar coordinates would be 3 pi.